Welcome to Epicenter, the podcast which talks about the technologies, projects, and people driving decentralization and the global blockchain revolution. I'm Sebastian Couture, and I'm here with my co-host, Mayor Roy. Today, we're speaking with Ali Yahya. He's a general partner at A16z. Of course, they are a massive fund, which bears no, I don't think they need any proper introduction. Everybody knows who A16z are and the type of the investments they've made. But we're going to be chatting with Ali today about a bunch of stuff, including A16z's thesis, also taking a step back and looking at fundamentals of crypto networks and some of the broader banking and political crises that have been happening around the world in the last few weeks and months. But first, Ali, thanks for joining us, and maybe starting off by giving us a little bit of background and how you became part of the team at A16z.
Yeah, sure thing. Thank you, Seb and Mayor. It's great to be here. Maybe I'll give you a little bit of my history. I was originally born in Mexico City. I was born and raised in Mexico, and throughout my childhood, I was fascinated by technology. I was very into engineering, into the things that humans have built. I was always in awe of things like, fast cars or planes or like tall buildings, all of the superlatives, like the kind of the great things that humans could build. And I was in particular fascinated by computers and by robotics and the prospect of AI and kind of that whole world. And very much wanted to pursue a career in engineering. And so I looked like toward the US as a place to study, as a place to kind of make a career. And in the end, I ended up going to Stanford to study computer science, focused on systems in particular. I really like to write code. And that was like the track that would expose you the most to large programming projects and programming experience. And so focused a lot on distributed systems, operating systems, computer networking, computer security. Those were all of the fields that were most interesting to me. And this was, by the way, my undergrad started in 2006. This was before crypto was a thing. At the very tail end of my undergrad degree in 2010, I was doing research with David Mezieres at the Computer Security Lab at Stanford, and that's when we all became aware of the Bitcoin white paper. I still have a few emails in the lab of us being like, "Oh, isn't this a cool thing? We should just play with it." And we all downloaded it, played with it, we mined it. But I think most of us, certainly I did, I missed the implications of how important it was going to be. So even though I was playing with it and mined it, I didn't track anything. I didn't track any of the private keys that I was mining with. And so that ended up being later on, 3 years after that, in 2013, when it started to become more clear what the implications really were. That was my first very visceral lesson in the space. And it became seared in my memory as an experience early on. And I feel like many people who've been in this space in a while have similar stories. But I was fascinated by it. So I kind of was following it closely since then. At the time, there weren't really many ways of working on it full time. And I was also, as I said, interested in AI. And so I joined Google. First I joined Google X, and I joined this robotics project called Replicant, which had been started by Andreessen, which was this agglomeration of a bunch of different robotics projects. And the mission was to build an operating system for fleets of robots. And that was nice because it kind of married my interest in distributed systems and then also machine learning and robotics. And so it was a very fun project to work on for 2 years. That ultimately, it was a project that was at X. It actually became the Everyday Robot Project, which is now a real thing. It's live. It's now public. You know how X is super secretive about everything, but it's now a project that people can talk about, which is nice. But after that, I moved over to Google Brain, where I did a little bit more of the same. It was distributed systems for machine learning generally, and I was working closely with the robotics team at Google Brain. It was a core contributor to TensorFlow to make TensorFlow more capable to work in that kind of environment. And then finally, in 2017, all throughout this time, by the way, I was still kind of fascinated by crypto. Google, of course, will never touch crypto with a 1,000-foot pole. So I could only really follow it and play with it in my own time. And my roommate at the time was Juan Bennett, who's the founder of Protocol Labs. So we were we were very close. We're like, he's maybe my best friend, and we were kind of contemporaries in school. And so we go way back. We were living together at the time and talking about all of this stuff. So I was fascinated by the space. At one point, I got connected to Chris Dixon here at the firm, and we kind of hit it off. And he essentially just said like, hey, you should join. We should start a crypto fund, because back then the firm was investing. Chris was investing in crypto. He's been investing in crypto since 2013 or so, but it was all entirely within the context of the main firm. So the thinking was we should build a dedicated team for crypto and really double down. And that was his pitch to me. And to me, that felt like a no-brainer. Like, I love the space. It's super interesting. I was frustrated that Google is just such a big company. It's very hard to actually get things done. So I jumped. I joined the firm in 2017. It was Chris and me at first, and then we started to build out the team. We recruited a few other people, and then since then we built out the entire crypto vertical here at the firm. And we're now up to 80 people or so across a bunch of different functions. And the idea is to not only make great investments, but to also support every portfolio company in every way we can. And I'm happy to talk a little bit more about the way that we tend to work with founders. But that's the story. It's been 5 years now, and it's been quite a ride, and it's been awesome. It's been really great.
That's a fascinating story. I didn't realize that your roots into crypto went so far back, and that, like many of us, you had been burned early by by not realizing the implications of what you were getting involved in. What you mentioned that you think that Google will never touch crypto with a 10-foot pole or perhaps even a longer pole. Why do you think that is, and why do you think Google hasn't embraced crypto? Because they're such like a forward-thinking company on so many other verticals and industries, but crypto seems to be something that they are incredibly hesitant to touch on. Although recently there were some announcements that they were implementing like in their cloud offerings, like some MPC services and things like that seem to indicate that they are open to providing infrastructure services to crypto companies, but at least like on the payment side or on any of the higher level aspects of the stack, they're quite absent.
Yeah. Well, I could go into an hour-long rant about Google that would consume the entire podcast. But I think that maybe the core reason that Google will likely never do anything significant in the space is just the classic innovator's dilemma. It's just the fact that crypto is such a disruptive technology. The fact that crypto works by being fully open, by being open source, and by decentralizing power as much as possible. The fact that that is at the core of what crypto is about is entirely at odds with the business model that Google leverages to survive. And so in order for Google to actually truly move into the space and actually do something meaningful, it would have to disrupt itself. It would have to disrupt the core business models that drive it today. And because as a company, it's no longer really founder-led, you don't have Larry and Sergey there as involved as it used to be. And because of the fact that it's atrophied in all these ways, and that it's become, I think it's fair to say it's become a more complacent company than it used to be. It's just very unlikely for them to do anything that disruptive. Everything that they do now, it seems to be much more incremental and seems to be in service of the core business model that has powered them this far. So yeah, I think I'm not holding my breath for Google to do something meaningful. They do have all of these like little experiments, because Google does still have this kind of freedom where you as an engineer, you can use your quote unquote 20% time and play around with things. And there are a couple of teams that are maybe experimenting, but it's hard to imagine that Google will actually invest heavily and make it a core part of what they do for all of the above reasons. And maybe that Google is like the IBM or the HP of our generation.
Oh no, for sure. I agree with that completely. I mean, at this point and sort of this size, the innovator's dilemma is probably the biggest culprit here, and that's the case for many companies, not just Google. We could say the same thing about Microsoft or Facebook, or although there have been some, I think, other types of interesting experiments there that might leverage crypto at some point, but in a very different form than what we know and sort of thriving for, I think, as people have been in the space for long as we have. So just maybe zooming in a little bit on A16z and the crypto team. You mentioned it's 80 people. What does that look like? And what are the key roles there? I'm curious because I'm also starting a fund, and there's a lot of things that I think I have to learn from other funds, and even though A16z is just a massive organization and is nowhere near the size that I'll ever aspire to get to, understanding sort of what the core support structures there are and support functions. Give us a bit of an overview of what the team looks like.
Yeah, of course. So the vision from the very start was to build a vertical within the firm that mirrored the original A16z form factor, but was very tailored for crypto specifically. And so originally, A16z as a firm, the whole vision from the start was that it's essentially a platform. It's a firm that not only makes investments, but is truly a partner end to end across many different functions to help the companies in our portfolio succeed. What that means for crypto is that because crypto has certain big differences from traditional companies, that there are things and ways that we can help that are fundamentally different, that require building out the team differently. And so as an example of that, one of the observations that we made was that because most of the work in crypto tends to be open source, because the work that's done tends to be out in the open, it's actually possible for collaboration to happen between organizational boundaries. And that means that as a venture firm, we actually can get involved in some of the core technical challenges that some of our portfolio companies are facing, which is something that would be much more difficult to do in any other sector of technology. Can you imagine, for example, in the world of biotech, or in the world of deep enterprise software, in order to get access to the code base or to the intellectual property that the company is working on, you really have to become a full-time employee. And so it'd be difficult in those worlds to contribute technically, to contribute to the core science and technology that each of our portfolio companies are working on. Whereas in crypto, it's a much more collaborative environment. The fact that it's all open source actually changes the game and makes it possible for us to build the research team, which is led by Tim Roughgarden. He's a former professor at Stanford. He was actually my professor. I took all of his classes, and these were some of the most interesting and hardest classes that I ever took. And he's a pioneer in the world of algorithmic game theory, and he's also extremely deep in the space. So in a sense, he's a bit of a unicorn. There are very few people who have the knowledge and breadth of the traditional literature, the academic literature around distributed systems and game theory and mechanism design, but who also deeply understand crypto and blockchains, and bring those two together to do
he's been on the podcast
research in the space.
He's great.
Oh, incredible! Yeah, of course. And he was actually the person who did the formal analysis of EIP 1559 and actually got the community, or helped get the community more comfortable with incorporating EIP 1559 to Ethereum. So he's the head of research, and under him we have a team of world-class researchers across cryptography, distributed systems, economics, game theory, mechanism design, and we're still kind of open to continuing to expand that team. And the idea there is that they can really help our portfolio companies, at the very least, understand what's been done before, and then also we can help them think through some of the open-ended problems that are actually research problems. And that team works very, very closely with our engineering team, which is headed by Eddie Lazarin. You may also know. So Eddie Lazarin is our CTO and head of research. And under him, we have a team of extremely senior, very they veteran smart contract engineers, security engineers, people who build things, and they work closely with our research team and our portfolio to actually produce production grade code. And so much of the work that they do tends to be open source. Again, the idea here is that we want to contribute. We want to help our portfolio solve open-ended problems, but we also want to help the community at large. So all of the work that we do is fully public. We publish all of the research papers and all of the research content, both in our website and then also in peer-reviewed conferences on the research side. And then we publish all of the code that our engineering team produces in our GitHub repo, right? So it's all open. So those two teams work closely with our portfolio, and there's a third important team which is very different from like the traditional venture side, like the kind of the main firm, and that is the regulatory and policy team. Because as you guys know, that's obviously like a huge open kind of question in the space. There are no bright lines as to what is regulatorily compliant and what isn't, and as a result, we have to be very smart about how we navigate the regulatory landscape. And so we have a team that includes people who have been extremely senior at just about every regulatory agency, including, for example, Bill Hinman, who was the person who actually established the framework for decentralization at the SEC, who established, for example, that Ethereum should not be considered a security, in part because, or largely because, it fails like the fourth prong of the Howey test, the fact that there's no managerial and entrepreneurial efforts of others, because it's fully decentralized. And so that whole framework came from him, and so he works closely with us and works with our portfolio companies to think through some of the regulatory constraints. And so then it's important to have both of those three teams, the research, engineering, and regulatory and policy teams, in the same room often with the portfolio company to be able to explore at the same time all of the possibilities on the research and engineering side, but then also the constraints. Like, how do you design a protocol that is also compliant and doesn't run afoul of like securities laws or AML, like other kinds of regulatory constraints. So those are three important teams that are fairly unique to crypto, and no other vertical at the firm has those teams just yet. And then beyond that, we have like the traditional teams that help our portfolio companies in the ways that you'd expect. So, for example, we have a big recruiting team to help our portfolio companies recruit at every level. Recruit both individual contributors, people like software engineers, product managers, generally product or UX people, as well as executives. So hire, like if you want to hire like a general counsel, for example, which is again super important given the regulatory piece. So the recruiting team is an important function. We also have the kind of the biz dev, market dev team, which helps with partnerships, and that team is connected to just about every team, every entity, every important individual in the space, and also outside of the space. So we want to connect our portfolio companies to potential partners, to exchanges, maybe also partners from the traditional world. Like if we want to connect them to a company like Stripe or Visa or companies like that. That team is basically the connector of everything. And then beyond that, we have the marketing team, which helps us basically produce all the content we do, but it also works closely with the portfolio companies to shape the narrative, to basically help them tell the story of their company. And we help, especially around important moments like announcements, or for example, if there happens to be some kind of crisis, we can really be helpful at managing the PR and the comms around moments of crisis. So that's a very important team. And then finally, we have the network operations team, which is the team that allows us to participate actively in all of the networks that we're involved with. And so that involves staking our tokens, for example, for layer 1 blockchains. It involves voting our tokens for protocols that have on-chain governance. It involves delegating our tokens to other players in the space so as to increase the decentralization of these networks. And so, for example, we have this delegate program that involves many university blockchain groups that are very eager to learn a lot about space and who would like to participate in some of the governance conversations that happen for protocols like Uniswap and Compound and protocols like that. So we very actively, we have a whole process for vetting the various different delegates that we can potentially delegate tokens to as a way of including more voices in the conversation and making the space more decentralized. So that was a bit of a rant. That's maybe the the full rundown of the various different ways that we work with the portfolio. And that's how the team is structured.
So Ali, for those of us who don't know a lot about the venture capital business, you started off as partner in the crypto arm of A16z, and then you became general partner, I think a couple of years back.
That's right.
What does a partner do, and what does a general partner do in this organization structure?
General partners are responsible for ultimately making investment decisions. And then the whole investment team works together at finding the best founders, being connected to everyone in the space, thinking through what our thesis for the space is. It's always an active conversation, and we have many meetings internally to discuss what we believe to be true and what we think might be interesting to invest in. So it's a fairly flat organization, and that everybody has a very active role in making any one particular investment. And then the one distinction is that ultimately a general partner is the one who makes the final decision of whether or not to invest, and also is the primary point of contact with the portfolio company thereafter. Though the whole team, again, like I just basically went through the whole team that ultimately the portfolio company will work with, and the general partner ends up being more of a router. Or like it's like, oh, you need help with recruiting? Well, let me connect you to Craig. Like, oh, research, Tim, like you should talk to Tim. Or there's an engineering problem, you should talk to Eddie. So it's really a team effort. Like I think we all work very closely together, and we're different from many other venture firms in that we really do work as a team, and it's not as if every investor has his or her own mandate and is like sort of, it's like survival of the fittest, which tends to be the case in other places where there's just less teamwork and each person is more of a solo actor. Here, we do have a holistic general thesis for the space. We all believe it. We've all kind of crafted it together. We debate it constantly, and we work closely together to make sure that all of our companies are supported.
Let's maybe talk about the thesis a little bit, or to the extent that, to whatever extent we want. We could probably talk about the thesis for a long time. So what is A16z's thesis when it comes to crypto?
Yeah, well, the heart of it starts with the insight, which I think by now is now better understood, that a blockchain is a computer. It's the best way to think of it is a computer, and it's not some sort of database or ledger or whatever. Yet, no, there are many other terms that people like to use to describe blockchains, and that the right model to think about this is a new paradigm for computation. It is a computer that has special properties. If you look back at the history of computing, every paradigm along the way has introduced something that's qualitatively different, and that's what kind of demarcates the different phases of computation, and that's also what allows for the kinds of applications that we can build to expand and to kind of bleed into more aspects of our lives. And so we started with things like mini computers and mainframes, and then we moved on to personal computers, and then we had cloud and mobile, and then the whole kind of internet chapter. And now we contend we have blockchains. And if you look at previous waves of computation, new kind of computing paradigms, like for example, take mobile, tend to actually be worse than previous paradigms in many ways. Maybe in most ways. Like for example, a mobile phone is a slower computer than a personal computer, and it doesn't have a keyboard, and it has limited battery life, and it has a small screen, right? And it's kind of maybe clunky to use at first, but it has one key feature that personal computers don't have, and that's that it fits in your pocket, and that it has a GPS, and that it has like all of these mobile features that actually unlock new kinds of applications that you couldn't have possibly built on a personal computer, which include things like Uber, for example, right? Or include all of the, the things that we love about like the mobile revolution, the kinds of things that people have built over the past couple of decades. So our contention is that blockchains, yes, like there are criticisms of them that are true, like for example, that they are very slow. Like a blockchain is a computer, it's a very slow computer, it's an expensive computer to run, but there are features that blockchains have that traditional computers don't have. And in particular, blockchains are a kind of computer that allow developers to write programs that have a life of their own. in a sense. These are programs that can make strong commitments about their own behavior in the future. These are programs that run without interference from anyone, from including the people who originally wrote them, including the people who run the actual physical machines that execute the logic of those programs, and including the people who interact with those programs as they run. These programs can run free of interference from all of those players. And that's a very powerful thing. And in particular, it's powerful because it can create a kind of trust that a normal program that runs in a computer that someone else controls cannot engender. One way of putting this is credit to Chris, is that blockchains invert the power relationship between software and hardware, where traditionally hardware has power over software because whomever controls the hardware can turn the software off or can change it and do whatever they want. Whereas in crypto, on a blockchain, it's the reverse. The software actually has power over the hardware. The hardware is actually just provided as a commodity by various different participants who have an economic incentive to participate, but who do not have any kind of control over what the software does. And that's a very powerful shift that has never happened in the history of computer science. Having a network and the software have power over the hardware, that's what's unique, that's what's different about blockchains. And as I mentioned before, the powerful thing about this is that it can create applications that have a different level of trust. The first application of that was Bitcoin, where the fact that you can trust that Bitcoin will only ever have 21 million Bitcoins, and that transactions will be processed in a way that is well-defined and that is valid, and that no one can really subvert the logic of how Bitcoin works. And that's the first example, but it's a very simple example, and we contend there's so many different things that you can do. Like now that you have this primitive, you have this kind of program that can make commitments, what can you build with that? And some of the applications that you could build might be financial in nature. Finance lends itself well to this space because of the fact that it requires trust. So you can build maybe more sophisticated financial primitives. Like that may be the whole like DeFi world. You can build exchanges that are decentralized, that have a similar property of trust, right? Or you can build a lending platform. You can build stablecoins. You can build some of the interesting DeFi primitives that people have experimented with. But you can also build things that have nothing to do with finance. And I think one of my favorite examples, which is fairly topical these days, is the whole world of social media, because you can conceivably build something like a decentralized social network that is truly decentralized and doesn't have a monopolistic $44 billion tech giant in the middle that can control who you get to follow, that can control who gets to follow you, that controls what you see and has like the one given algorithm, the one given curation mechanism that controls what your feed contains. And instead, you can build something that is decentralized, where you as a user control your own identity. You as a user control who you get to follow and who gets to follow you. You maybe even control the algorithm that's used to curate content, and you have control over your feed. And there could be a whole marketplace for different kinds of recommendation algorithms that is competitive and people participate in it. And then you can do that with crypto in the same way that you can build Bitcoin. And it has the same property that you can trust that the network will maintain and will commit to certain rules that will be upheld throughout time, that cannot be changed by some kind of central operator. So that's basically the heart of the thesis. And there are many implications to that, but that's where it starts.
Yeah, that's an interesting way to, I think if you ask a lot of people today, what is a blockchain? I think like 90% of people will say it's a decentralized database, or it's like a decentralized ledger, or this idea of a decentralized ledger still permeates, and I think there is a shift, in narrative in the industry that is leaning more towards this idea that it is a computer, and like it sort of started that way, right, with Ethereum as the world computer, and then it went to decentralized ledgers, like in the whole like mid 2000s or 2010s with like enterprise trying to build whatever their private blockchain. That whole thing failed.
And blockchain, not Bitcoin. Exactly.
Yeah. And so I think a lot of that narrative came from that, and now it's from what I'm seeing, like teams that we're looking at and the narratives that we see, at least like I'm fairly well connected, like in the interchain ecosystem. Those narratives are starting to come back again, and I think it's quite positive because it really does, I think, align well, like you said, with the evolution of computing. And it might very well be that if you go back to that example of mobile enabled new types of applications that are well suited, like for people who are not stationary, right? It's like they're applications that are well suited for mobility because they're mobile, right? Where here, the types of applications I think we will discover is types of applications, and sort of like self-serving is what I'm about to say, but types of applications that will require trust in a person or in an entity. And what we'll realize, as crypto and decentralized applications become more mainstream, is that this will be the defining factor. And yeah.
So, Ali, you've started off with the premise that these blockchains are distributed computers, and the key property is that programs running on these computers are able to credibly commit something about their future behavior to participants. And because they're able to credibly commit about future behaviors, they naturally end up getting applied to finance, because those sorts of commitments are important in finance.
Yes.
From this viewpoint, do you see particular verticals in the crypto area, verticals of crypto that are kind of especially good or especially bullish about? So what I mean is, when you scan across crypto, you have the crypto gaming area, then you have the storage area, or like computing services area, then you have DeFi, then you have these exchanges, you have this data sharing area, data DAOs, etc., right? Are there any particular areas that you are especially bullish about and believe that in 20 years, that those one or two areas are going to be the massive successes, the power law successes?
Yes, absolutely. So I think one of the other ways in which trust really plays an important role in the world of software is this notion of platform risk, which historically in the Web2 world has been a huge source of risk for any startup that is potentially building on top of some other companies' APIs. And I think we've all kind of seen this. There have been many startups, for example, that built on top of Twitter APIs a long time ago. Remember, like Tweety, and there's this whole kind of set of companies that were doing interesting things and composing different kinds of Web2 APIs. But then ultimately, because those APIs are controlled by a centralized company, the central company can change the rules and can decide to move against the startup that is starting to get big and instead charge more, or instead like change something about how the APIs work such that the central company captures more value, and then maybe the startup ends up dying. And this has happened time and time again, right? There's certainly kind of like the Tweety Twitter example. There's Zynga Facebook. And this also, by the way, dates back to kind of the world of operating systems, where you have operating systems like Microsoft Windows also subverting the functionality of some of the applications that are built on top. So platform risk has been a theme in technology and software for a very long time. And I think it gives you some insight as to how crypto can be used for things that are no longer financial in nature. So when you can build a program that has a kind of API that is committed to, that the program commits to not changing, then you've neutralized platform risk. And it as a result allows startup companies to build on top of that program in a way that it is no longer possible in the world of Web2. Like these days, if there's a company that comes pitch us, for example, if they come to pitch our main fund, the consumer fund, with an idea to build a product that depends entirely on the APIs of Instagram or the APIs of Google or whatever, that's a non-starter, because it is now very well known that won't work. You cannot build a massive company on top of the APIs of a company like that, because at some point, sooner or later, whomever runs that centralized company will change the rules, and that they will want to capture more of the value, and it just doesn't work. So now I think this is by the way what enables composability in the world of crypto. The fact that you can neutralize platform risk, the fact that you can actually build on top of Ethereum and not worry that Ethereum will change the rules on you and will try to take a bigger cut of the money that your product makes. That's huge. And the fact that continues even above that, right? The fact that you can build a product or a startup on top of, say, Uniswap, right? You can build a startup on top of some of the applications that are already running on top of Ethereum, because those applications also make commitments that you can actually trust. So I give you one example of a vertical or of a sort of an area that's super interesting, which is that of social media, like decentralized social media. The fact that you can build a decentralized social network that has rules and has APIs that can be trusted in perpetuity is very interesting, because now you can have a social network where the social graph is kind of like a public good, right? That exists on chain, that is owned collectively by all of the users. You own your node in the graph, and other users own their own nodes. And then all sorts of startups can build on top of that same social graph. You can imagine a startup building one particular client that gives you one view into the social graph, and that maybe decides to curate content in one particular way, but someone else can build a client too that's different, that has a different interface, that maybe like highlights different kinds of content. Maybe one of them is kind of like Instagram and another one is more like Medium. I don't know. But it's the same social graph, and this is what enables the composability. And none of those startups that are building on top of the social graph have to worry that the rules will be changed from underneath them, and that as a result, they'll go out of business. So that's one very interesting vertical where this notion of platform risk plays a role, where crypto, I think, and the trust features that crypto provides really make a difference. But there are many others. I think another one, as you mentioned, gaming is another interesting area where you can look at the history of gaming. You can look at examples like Fortnite, right? The fact that people pay a lot of money for in-game items that are purely cosmetic, right? The fact that these in-game items don't actually change gameplay at all. They only change the way you look in the game, or the kinds of little emotes that your character can make. And it's like a multi-billion-dollar run rate business. That's fascinating, because the company at the center of it has full control over that economy. Imagine if you could actually build a crypto economy into a game such that the in-game items that you buy are actually yours, right? Such that you can actually take them out of the game and maybe even take them into another game. If it's a standard, for example, that multiple games begin to support, then maybe your character isn't just specific to one game. You can actually take it from one game and into another game. And this becomes a much larger economy that spans multiple different kind of digital universes. And this is what people like to call the metaverse, which has now become a word that has been co-opted and it's very overloaded. But it's an interesting idea, and it's born bottom up. And again, the trust features really matter here, right? Because it's important that you trust that you actually own the things that you own. That's what allows this ecosystem to emerge. So that's another interesting area. Maybe a third one, and then I'll stop ranting, is the area of media generally, and maybe I'll lead with an example. So we're investors in a company called Sound.xyz, which is a decentralized music streaming platform, which I think is a super interesting application of crypto. If you look at the music industry historically, the record labels have an inordinate amount of power. And the reason for that is that they control the catalog. And so a company like Spotify, for example, cannot really negotiate against the record labels, because any one of these record labels controls so much of the historical catalog that if they pull out, Spotify becomes almost unusable, because now it's missing like a third of the music. And its whole value proposition of being able to provide you with every song that you might want to listen to is no longer held up. So the record labels have enormous leverage. They take a huge cut, and then Spotify has to take a cut. And so therefore, there's only a sliver that's left that it actually goes to the artist. So the artist is royally screwed. And if you actually look at the numbers, there's something like 8 million artists on Spotify, and only like 14,000 of them, so 14,000 out of 8 million, make more than 50K per year, which is hardly a living. Which is to say, basically, no one makes any money on Spotify. The only people who make money are like the very head of the distribution, the kind of the Taylor Swifts or the sort of the Jay-Z's of the world. And then everybody else makes 50K or less, likely much less. In order to actually make any kind of money on Spotify, you have to have millions, if not tens of millions or hundreds of millions of streams. It's insane how much traction you have to have as an artist to make any money on Spotify. So sound is a little different. So you guys remember SoundCloud from before. SoundCloud was this nice kind of music service. You as an artist can upload music, and it had this cool feature, which was that you can, as a user, you can comment on the track as it plays on the website, such that other users can then see your comment, right? So as the music plays and it rolls over the time at which you left your comment, they can see what your comment was, which was like a cute idea. It created this kind of social dynamic around a piece of music. So Sound took that idea, and their initial product idea is that you can actually make that comment an NFT, meaning that, say, as an artist, you upload a piece of music, and there's 100 NFTs for that piece of music. Whomever buys those NFTs, if you have one of those NFTs, you now have the right to add a comment to the track. And if you sell your NFT, then the comment disappears, and then whomever holds the NFT now, the new holder of the NFT, can now add a comment as well. So this creates a bit of a little market, right, for these NFTs. The beauty of it is that 100% of the money that is recouped from the sale of these NFTs goes to the artist, or maybe like 95% of it, and then a small percentage of it goes to Sound, the protocol. So that's great. But the more important piece of this is that as an artist, you now have a direct relationship with your super fans. These are the people who are willing to buy an NFT to add a comment to your track. These are the people who truly believe in your music and who truly like your music. And it's not only a relationship, it's an economic relationship. You know the crypto wallets, and that's a community. You can now start doing interesting things. You can, for example, do like backstage passes for the people who hold any one of these NFTs. Or you can have like a Discord group that is token gated, and only people who have NFTs of this kind can access it. Or any other kinds of benefits where you as an artist now have like a more direct relationship with your fans. And it's connected to this idea. There's this great blog post by David Kelly called 1,000 True Fans, which argues that all you need as an artist or as a creator to make a living online is 1,000 true fans. And his logic is, if you define a true fan as someone who pays you $10 a month, then if you do the math, right, 1,000 true fans, each paying you $10 a month, that's $120,000 a year. All you need is 1,000 true fans. Clearly on Spotify that doesn't work. You need millions of fans to actually make any kind of living. But if you had a more direct economic relationship with your fans, you can actually make a living. And so Sound is basically exploring how you can use crypto to do that, right? As an artist, you can build a community of true fans and have an economic relationship with them. And if they pay you at least $10, that's more than you could make on Spotify. And so far, by the way, they've paid out like $5 million. It's not
as a content creator, getting to 1,000 true fans, even for just $5 a month, is not easy. Ask.
It's not easy.
it's not easy to get there, but making it easier for that to happen. And things like Patreon have definitely shown how this model works, right? Like I think Patreon has a similar type of model and one that is very different from, say, like a Spotify model. But I think like there were probably just as many musicians 50 years ago that were making $0. They just weren't streaming. But I mean, of course, like the platform allowing this, does allow opportunities for people to achieve those goals. There was one thing you were mentioning earlier about the platform risk, and recently in the last year or so, I used to have this idea that like blockchains are immutable, the rules that are embedded in the blockchain and the smart contracts are immutable, and like that's it. And you could sort of like deploy there and be assured that like your code will be run in perpetuity forever. And then And then there was the whole Juno whale thing. And I don't know if you followed this this particular part of Cosmos drama, but essentially a governance vote on Juno, which is a smart contract chain in the Cosmos ecosystem that runs Cosmos smart contracts. A governance vote decided that funds that were held essentially by an individual who had received airdrops, for reasons that I'm not going to get into here, were to be clawed back essentially, and because the rules of the airdrop had not specified certain provisions about people holding other people's funds or whatever. There's a whole blog post about it, and then if that's not enough, the people who were meant to take those funds and sort of transfer them into a treasury so that they could be effectively managed or whatever, made a mistake when transferring the funds and lost like tens of millions of dollars, or maybe even hundreds. I mean, it was a massive catastrophe. But it just showed me that I realized that, you know what, like blockchains do have this immutability aspect, and sort of like this platform risk assurance when they arrive at such a state that governance is solid enough that if governance and incentives are aligned such that validators are not going to screw, the user base or account holders. And I think there's a delicate balance between, validators, users, and application developers that really mirrors kind of governance that we know and sort of from our everyday lives and democracy and sort of like human governance. But when it comes down to it, like blockchains are a mechanism for executing human decisions, and the power balances that exist in the real world can also exist in blockchains. How do you reason about that when thinking about this whole idea of platform risk and eliminating platform risk?
Yeah, it's a really good point. I think that the way to think about this is that a blockchain gives you an enormous design space, on top of which you can build all sorts of different things, including different kinds of governance systems, which I think is it's a really exciting thing, because now it is possible for 1,000 different companies who are building different ecosystems to run 1,000 different experiments about how to run a governance system for their community, which actually gives us insight about governance generally. And it gives us insight that maybe can translate to beyond crypto. And it's in a way that was impossible before, where like, I think before crypto, if you wanted to test a new kind of sort of political governance system, you had to spin up a whole civilization, institute your new experimental governance system, wait 10,000 years and check to see if everyone has died or if it has somehow fared well or not. Whereas now it feels like you can run much more isolated experiments with a network that maybe does one simple thing and has a community that governs it. You can come up with a new governance system that hopefully does better than other governance systems, and some will do well and others won't. And I think over time, we will figure out what the best practices are. Maybe we conclude that one token, one vote is not the right model because it leads to a kind of plutocratic outcome. Maybe we conclude that the governance system has to be restricted in some way so that you can't claw back tokens. Maybe that's not something that's within the purview of the governance system. Maybe we conclude that we need different kinds of stakeholders. Like maybe you have token holders as one camera in the governance chamber, and then there is also like actual applications or drivers of volume or drivers of activity in the network that also have some say and have some ability to participate in the governance process. It's a very big design space, and I don't think we found all of the answers. And I think that some of the initial experiments are interesting. I think, for example, Maker is pioneering. What pioneered, I think, one of the initial models for governance with the MKR token and the way that governance works for that whole system, which is very complex. But it was interesting. I think we learned a lot from it. And also, Compound was also initially one of the pioneers on token-based governance with their governance module. I forget actually the name of the code file, governance alpha or something. And I think since then we've seen many other experiments, and it's exciting to see, I think, what new things people may try, and along the way there will be failures like the one that you described. But I just think that that's part of the learning process.
In my crypto journey, one of the things that I found very hard is making sense of crypto token valuations. By that I mean is, pick any random coin, and you often have the sense that, okay, if this coin is trading at 100 million, that's awesome. And if it's trading at 10 billion, I'm not going to buy that coin, right? You often have this kind of gut instinct where what you invest in depends on the market cap of the coin you're looking at. Yet there is no good way to quantify or think about it logically. So I'm actually curious how A16z as professionals that make these decisions day in, day out, how do you think about valuation and what makes sense and what doesn't?
Yes, it's a great question. Well, and I think this often is a conversation that we tend to have on a case-by-case basis, because it very much depends on the kind of network, the kind of protocol, the kind of product that we are looking at. And there are different models for different kinds of things, especially when it comes to different layers of the stack. So, for example, maybe we can work through the stack. Something that exists at the user interface, like client level, an application that's maybe communicating with protocols that run on chain, but that it in and of itself isn't on chain, and that maybe has a more traditional business model, right? Something like a wallet, where a wallet's business model is to potentially just take fees on all transactions, or something like this. That's straightforward. We don't have to spend too much time on that. We use traditional methods of reasoning of evaluation in that case. If we move one level down, like there may be applications that run on chain, that are protocols that, for example, like run on top of Ethereum, and this could include some of the DeFi protocols like Uniswap or Compound, or like applications like I mentioned, like Sound.xyz as like an on-chain component. It's a protocol that runs on Ethereum. Oftentimes, in those cases, this is, by the way, I think apparently like a misconception about the space. People think that all cryptocurrencies are just like fully speculative. In most cases, there is still some notion or something that resembles revenue, right? Where there's like a fee that's being taken by the protocol on chain. The fee accrues to some on-chain treasury, and the token has some claim on that treasury, or has a potential claim down the line based on governance, potentially, in the same way that maybe the shareholders of a company have a claim to the assets on the balance sheet and to future cash flows. Token holders similarly have that kind of claim over a protocol's treasury. Of course, it's fully decentralized, right? So there's no company. When we're talking about the protocol, there's no company that controls the treasury, and it's just a broad ecosystem, which is, by the way, it's why the token is not a security. The fact that it's a fully decentralized ecosystem where there aren't any asymmetries of information. It's just all on chain and it's all open source. So for those networks or those protocols, it's also reasonable to think of it in terms of the traditional methods of valuing a company. Like, what is the current revenue, the current cash flow, and what is our thesis for what that might look like in the long-term future? And we believe that this protocol will somehow become like a fundamental piece of the crypto world, and if crypto is going to ultimately reach billions of people, then you can make some argument for why it'll be much bigger than it is today. But the methods are still fairly traditional in those cases. And then there's the question of how you would value a layer one blockchain. So something like Ethereum, for example. The good news is that even a blockchain like Ethereum, which is a layer one blockchain, and the token serves many different kinds of purposes, also has a notion of revenue. And that comes in the form of ETH getting burned with every transaction, thanks to EIP 1559, that is a form of revenue because it is taking ETH out of circulation, and that's mathematically equivalent to essentially doing a distribution of that amount of money to all ETH holders. So you can use that at least to reason about the value of ETH, but there are many other drivers of value for the ETH token. So sort of the fact that ETH is used for staking makes it a kind of productive asset, such that you can actually earn money by holding it and owning it in the way that validators and the networks do. And that drives some value to the token because it's a productive asset. You can think of it as capital. It also is the currency with which everything gets paid for in the network. You need ETH to pay for computation in the network, which means that people have to buy it to be able to use Ethereum, to be able to participate, which is another driver, which gives the token a kind of monetary premium. People begin to think of it as kind of money that is also maybe a good store of value, and as a result, they probably just hold some amount of ETH longer term, which drives value to the token. So that there are a number of different, and there are more. I mean, I think we can keep talking about the drivers of value for a token like ETH, but we tend to think of all of those things and try to, at the very least, get some quantitative sense for how all of these interplay. But it's very hard. It's very hard to make it a very quantitative analysis for what a layer one blockchain should be worth. And people have tried. I'm sure you guys have heard of basically the application of the equation of exchange to layer one blockchains, which is that equation MP equals to PQ, which is used to value foreign exchange currencies, like one currency with respect to another. You can think of Ethereum as a kind of like a sovereign nation state that has its own currency, namely Ethereum, and it has one export, and that's decentralized computation. And then you can apply the equation of exchange to try to value ETH in that way. And there's a term there, which is the velocity of money. Like the more ETH gets transacted, then the less valuable it is because it's not being held. So that's the intuition. But if you actually use that model to try to predict the price of ETH, you're going to be completely off. So we take all of those factors as inputs, and then we think about what the future might look like. If we believe that, and there's a whole thesis that we have about how there will likely be a handful of winning smart contract architectures. There won't be 1,000 and there won't be one. There will probably be a handful, in the same way that there's a handful of winning processor architectures. And the winning ones will likely be, if we're right about crypto, and crypto will reach billions of users and will become this mainstream phenomenon, and a whole world that's akin to Web 2 will be built on top of Web 3, then we strongly believe that each one of these winning smart contract architectures will be worth many, many trillions of dollars. So that's kind of how we think about it, and we just try to imagine what that future looks like, and then backtrack from there to try to make an argument about what the token should be worth today, and then make investment decisions in that way.
So one curiosity is, so it makes a lot of sense, right? If your wallet, value it as a traditional business, okay, present value of future discount, present value of future cash flows, easy. When it's a protocol, well, if it's a protocol like Uniswap, you can still view it that way. The Uni token maybe viewable that way, and you can have some kind of rational model for it. When it comes into Ethereum, you can have a rational valuation for it, but then there's some kind of premium that needs to be added because the market is attaching some kind of monetary premium. And if you ignore it, it's going to be hard to justify the values at which ETH is practically trading in the market. And then maybe when we get to Bitcoin, well, you really can't see any good revenue stream at all. And then it is entirely some kind of monetary premium, which may be really hard to approximate. Do I get that right? And then, so my question would be, do you think other L1 tokens will also have monetary premia in the future? Or is the market kind of already won by Bitcoin and Ether?
It's a good question. I think that to touching on this, on our thesis for why there will likely be a handful of winning architectures. The thinking is that no one blockchain can fully cover the trade-off space. There are many different things that you can be optimizing for. You guys may be familiar with the scalability trilemma. There are a number of different optimizations that you can try to make, and it's very hard for a single architecture to just be the god blockchain that like basically takes the whole thing. And this is similar, by the way, to just traditional computing, where you have CPU architectures that are intended for general purpose computation, like x64 and ARM and things like that, which, by the way, themselves have big differences between them. But you also have different kinds of architectures that are optimized for completely different things, like GPUs that are optimized for parallel compute and optimized for gaming. And now, well, they turn out to actually work quite well for machine learning and AI. And so similarly, we believe that there will be a handful of different kinds of architectures for smart contract platforms that collectively cover the entire trade-off space, but no one architecture will just win everything. And I think that's maybe the reason for why there won't be one. And now I also have to make the argument for why there won't be 1,000 of them. And the reason there is that there are very strong network effects. And so if you do have two blockchains that are fairly similar and not differentiated with respect to one another, I think that the equilibrium state is for one of them to ultimately win. And that's because of the self-reinforcing feedback loops involved, the fact that there are network effects at every level. There are network effects at the security level, because as a validator, you want to validate on the blockchain that's most secure and the blockchain that will give you the biggest reward, which is the blockchain that has the highest token value. And so that results in a self-reinforcing feedback loop that likely causes one blockchain to win. There's also network effects at the application level, where because of composability, you want to build your application on the blockchain that has all of the other applications, because you can use those other applications as building blocks. This is the whole notion of like Lego building blocks. In crypto, the fact that there is no platform risk allows you to leverage other smart contracts that are also running on the same blockchain as inputs to your own application, and you don't have to necessarily reinvent the wheel, which is another reason you're more likely to build on top of Ethereum than you are on top of a random new blockchain that has nothing on it. And then the same applies at the integrations level. Like if a blockchain is already integrated into all of the exchanges and all of the wallets and all of the interfaces and clients, a new blockchain has a hard time displacing all of that and competing against all of that. So the network effects, I think, reduce the possibility that there may be many different blockchains that are all identical to one another. And so that, I think, precludes the possibility that there will be 1,000 blockchains. And so as a result, like I think my strong belief is we'll probably end up with something like 5, I don't know, like some handful of different kinds of architectures, all of which will likely be very big, because it's a small number that support all of the decentralized computation in the world. And I think as a result, it's likely that token for each one of them will have all of the same factors that drive value for ETH, right? Including the staking, including the fact that there is a monetary premium because people use it to pay for things in those ecosystems. But take all this with a grain of salt. We'll see. It's very hard to predict the future. This is just one way to look at it.
In your experience investing in some of these protocols, I'm sure like A16z comes across the case where the split of revenue may not be clear at the time of investment. What I might mean is, like, maybe I can only take a practical example, like the Uniswap case. So where you have Uniswap Labs who built the protocol, and for a long while did not actually want to launch a token. And then out of the competitive dynamics with SushiSwap, they were forced to their hand was almost forced to go into that direction of launching a token. And when I personally look at Uniswap, like a rational valuation of the Uni token is made for me hard by the fact that how does the revenue get split between these two entities? There are many of these protocols in which there is like rational valuation is made hard by the fact that there's a foundation and there's a community treasury, and the dynamics of that may not be clear upfront. Now, for me, as an external like market participants, the only thing that is available is the unit token. But for A16z, in such cases, you would have the option to invest in either the public token or the founding team. Do you have any kind of general guidelines for when to prefer one over the other, or how to think about this trade-off space?
Well, we primarily invest very early stage, and at that stage, it's often too hard to know whether the value will ultimately be captured by some token that the team decides to build, or whether it will be captured by a company, a traditional company that the team builds on top of some protocol that maybe is just open source. And so as a result, the structure that we've landed on is one where everyone involved, that includes the team, and it also includes investors like us, should get both things. They should get both an equity stake in the company. In the case that the team decides that that's the path that they will take, maybe they decide not to even launch a token. Like maybe the tokens are the wrong thing, and they just want to build a traditional business, and it's too hard to know that a priori. So in the case that happens, you want everyone to have equity. And then also, I think if in the end it is actually a token thing, and the token is what captures the most value, you also want everyone to have the token. And the reason this is important is just for alignment reasons. You just want everyone to be on the same boat. No matter what happens, if the company succeeds, everybody succeeds. No, and this also, by the way, maximizes flexibility. It doesn't constrain the founder to absolutely necessarily launch a token because the investors expect that, or to just build a revenue earning business, again, because the investors expect that. As investors, we are on board. We're on your team no matter what, and everyone's aligned. And we found that is actually the best structure. And we don't try to predict a priori, where the value is going to be captured, because that can impose constraints on the founding team that you don't want to impose that early.
Yeah, that's really interesting. And, I think, for us, as we think about how we want to construct our portfolio, this also aligns with what we look for when investing, and certainly, there has become, I think, a sort of standard that most teams raising in crypto will raise on a sale of future equity agreement, and then a token warrant or something like that. So it is quite commonplace to have that sort of agreement with teams that are raising. Maybe just before we wrap up here, one final thing I wanted to touch on. I mean, taking a step back and looking at the events of the last couple of weeks, is how has the firm change, or say, how does the firm advise companies and teams in your portfolio to protect themselves against, a potential banking crisis, or the shutdown of, perhaps like the bank that they're working with, or more broadly, an economic crisis that might, have their treasury be wiped out, or to some extent, even regulatory risks. Like, how do you approach these sort of, risks that are inherently tied to the system in which crypto operates, in order for teams to be better prepared against these types of events?
Yeah, it's a really good question, and it's a hard one. I don't think that there's a truly great answer. And by the way, I think that everything that's been going on with the banking crisis is actually just a reflection of the failures of centralized finance. So in a way, like, it kind of highlights the reasons that you actually need crypto, and being able to have the transparency such that you can tell, whether an organization or a protocol is solvent or not, is part of the essential ethos of the space. But given that we are still embedded in the traditional financial system and our companies still need bank accounts, our advice really just comes down to diversification. You want to not be entirely concentrated with any one bank. You want to maybe split up the company's assets across 3 banks or so. Maybe you could hold some amount of capital on chain in the form of USDC as well. Like it's another way of diversifying. But that's really ultimately the only answer. Like barring like most companies in the space at the moment cannot get bank accounts with the big like GSIB organizations, like the banks that are so big that they're too big to fail, because those banks don't want to bank crypto companies. And so then as a result, the only other option is to maybe get 3 bank accounts with other more regional banks that are more friendly towards crypto as a way of minimizing the risk that any one of them might fail.
Yeah, I think that's sound advice, and certainly it's what I've encountered so far in the last few weeks as the dust has settled and people are starting to reason about how they want to reduce that risk. And certainly for us, we were we were about to start working with one of the banks that was shut down, and now are thinking, okay, well, I mean, we probably need to engage with several banks.
Exactly.
Let's reset up our structure, so that makes a lot of sense. Yeah, this has been really fascinating. I really enjoyed this conversation and all the insights you provided here. And so would like to leave our listeners with one final thing. Where can people find you, or some of the things that you mentioned, the work that A16z is doing, the research, etc.?
Yeah, absolutely. So we are A16zcrypto.com for all of the A16z crypto specific content, and that's where we all are. That's where you can find us. And then personally, I'm on Twitter at alive_ETH.
Great. Thanks. Well, Ali, thanks for coming on the podcast.
Thank you so much, guys. This was so fun. Really appreciate it.